Hey guys, Mike teaches programming here, and this is a new series called Creating a Java Spring Boot Microservice. This is part one of a three-part series. So part one, what we're going to do today is create a simple Java Spring Boot project, and we're going to Dockerize it. So what it's going to be is a little library service, and it will contain one endpoint, a get endpoint that will return a list of books. Then what we're going to do is Dockerize it. Then for part two, what we're going to do is add an API gateway, and we're going to use Docker Compose to spin up our API gateway and our library service together. So all requests will go to the API gateway, then be forwarded to our service. Then for part three, we're going to throw in a discovery service so that all the microservices know where each other are. So yeah, let's get started. Today, pretty simple. Let's just create a new project. I'm using IntelliJ, Spring Initializer. This is kind of all your Maven settings. So what I do is com.michael. Again, if you guys want, leave comments on what you want me to go into more detail in. So I assume that you guys know Maven, so I'm not going to go into too much into Maven or the annotations for Spring Boot. Just follow along, and if you guys want to see videos later on explaining these, then I will do that. So again, just making a library. I just call it com.michael. Yep, all looks good. I changed Java version 8. Here is where we add the dependencies for our project. So really all we need is Spring Web. You can see we have a lot here, like Lombok to remove getters and setters and different kind of dependencies, but all we really need is Spring Web. So click next, and project name is library, click finish. So as you can see, that generates a new library project for us. And if we go to our POM, we can see here that the parent is Spring Boot. It added in our web dependency and test dependency also. So what I just want to quickly add in here is packaging. We'll set that to a jar file. Okay. So next thing we need to do is, you can see here that what's generated for us is a library application class. So we can run this up now. It will work, but there'll be nothing there. There's no controllers, no endpoints to do anything. So what we need to do is create a new package, call it controller. Now what we're going to do here is make a Java class and call it library controller. Okay. So what I want to add in here is I want a method that, or I want a REST endpoint that is a get, and I want it to be on /library /books, and that will return a list of books. Okay. The first thing we do is annotate this with REST controller. Again, this is a annotation provided by Spring Boot and kind of web dependencies. And then what we want to do is go request mapping, and I'll set this to the value is library. Okay, let's go /library. So that's this part kind of done. Okay, we haven't got a get method and we haven't got the books for it. So let's do that now. So I want one get mapping. The value is going to be books, and it's going to produce media type application JSON value. Okay, and then we need a method to go along with that. So it's a public response entity, and what we're going to return is a list of book and get books from library. Okay, and it's going to take in nothing, and it's going to return. Good. So this here is response entity, pretty standard stuff, and it's going to return a list of books. So you can see it's complaining about books because we don't have the model created yet. So let's go ahead and create that model. Again, under library, create, what did I do there? Create a new package and call it models. I just call it model, and then inside model, let's create a new Java class, and we'll call it a book. So inside here you define all of your parameters for the book class. So all we're going to add is a private string name, and underneath here we'll add our getters and setters. So generate getter and setter for name, and that's okay. JSON property order means how the JSON is going to be returned to the user. So if I had two parameters, name and author, if I didn't have this, then it would be the order of the kind of book class would be name, then author. But what I can do is define what order the return up here. So author, then name, or name, then author. So yeah, back to the library controller. Let's import this book, and we also import list. So now we need to return something simple. So let's create a list of book. I'm gonna call it books. Array list. Okay. And then we'll create a new book. And we'll call it like book one is equal to new book. And what we want to do is set that name. So let's get set name. We'll call it Harry Potter, because that's original. Okay, and then we'll just create another book. So I'll just copy and paste this. So I'll just do this simply so you guys can understand and see what's going on. And we'll call this Avengers. Okay, and it's still complaining the method because we don't have a return. So what we need to do is we need to return something. And what we need to do is return the books. So let's return a new response entity. And inside here it takes two parameters, books, and the second parameter is the status. So a HTTP status OK. So you can return OK, or if you're posting something, it will be created. So that's our simple method. Usually here you'd connect it to like a MongoDB, and your GET request would query the MongoDB, and you would return the list of books that's stored in your DB. Maybe we can do that in the future if enough people start watching this and want me to show you a video on how to do that. Sure, we can do that. But anyways, this is the most simple, basic service for now. It's a simple Java Spring Boot service. I wouldn't even consider it a microservice because it has none of the other architecture, and it's not kind of in a Docker container yet. But it is kind of a microservice as it does a little something small. So again, let's just test this and make sure it's working okay locally. So what I use to test is a program called Postman. So after we run the application, again, you can run it from here, the library application. You see here that it started on port 8080. If you wanted to change that port, just click in here into resources, type in new file, application.yaml, and you can change the server.port and change it here. Okay, so I'm going to keep it 8080 because I don't really need it, but if you need to change it, just change this port and it'll spin up on whatever port you want. So again, going back to testing this, what I use is a program called Postman. Okay, so once you download it and open it, it will look like this. So I have been testing this before I did this video, but let's see. So you click on the new plus, and we're making a GET request to this controller, library books. So let's open it again. So it's a HTTP /, I have it wrote down here somewhere. Just change the port back to 8080, library books, and let's send that GET request. And as you can see, it returns an empty array list because I didn't add the books to the books array list. So if we go to books dot add, and we'll add book 1 duplicate, and let's add book 2. I could have just added 2 book 1s, but anyways, let's run it again. And once it spins up, we should be good to go. Okay, yeah, ran on port 8080. So what I'm going to do is run this again on library books, And you can see here that we get the JSON back that we expect. So it's an array list of two objects, one being the book called Harry Potter and the other being the book called Avengers. Again, there would be more fields if it was an actual object coming back from a DB, a database, but for simplicity, this is what we're going with. So that's our simple Spring Boot service. The next thing that we've got to do is we have to build this into a Docker image. So Docker image is containerizing this kind of this application so we can run it in different containers. So I'm not going to go too much into Docker, but what I am going to do is show you how to use Docker and spin this little application up into a Docker container. So the first thing we got to do is we've got to generate a jar file. So if we go back to the start, I added in packaging.jar file because I want this application to build a jar file for me. So if we click here into Maven, or you can do it in the terminal, whichever you prefer, just type in Maven clean install. Again, you can do it from terminal, just write Maven clean install in the directory, and it will do the same thing. I like to do it from here. So again, what this is doing is it's running Maven clean install. It's going to run all the tests. You can skip the tests using dskip tests. Just Google that, or I'll leave it in the description. But we have no tests, so it's going to be just as quick. So as you can see, what that does is it generates a target folder. And inside this target folder, we can see that it generates a jar file. Now this jar file is pretty much this application, so that I can give it to any machine that has Java, and they can run this jar file. So I don't really, it's named it library for dash the version. What you can do to change that is if you go into the POM file, under build, if you type in final name, I think it is, no, give it a big N, yep, final name, and if we call it library dash service, and then if I do a Maven clean install again, just refresh this, and we can see what happens inside the target folder. So just keep an eye on the target folder here, and you can see here that the jar file is now named to our service. So I'm just doing that for simplicity's sake, but if you were to version do stuff, it might be better to include the version if you're adding versioning into your projects. But for now, let's just do that. So the next thing to do is let's use Docker to containerize this. So I showed you how to run it by using the main class, but let's run it using Docker. So the first thing to do is create a Docker image. Now the Docker image is pretty much, what you got to know in Docker is that there's two main components. There's a Docker image and a container. Docker image is pretty much a list of instructions, and it tells your container how to run this application. So what you want to do here is click library, new. Actually, before we do that, I just want to make sure that you guys have Docker installed. So if I open a terminal here, if I type in Docker, you can see I get a list of commands, okay? So make sure you do that and install Docker. It's pretty easy if you're on Windows 10, just follow the instructions. I'll put a link in the description anyway. Okay, so yeah, back to here, right click on the library, your top project, and click new file, and just call it Dockerfile. Okay, now Docker files can be as large as you want them or as small. So we're going to do a really small. And the first one that you always want to include is a from. So I'm copying from a different Docker file to my left here that you guys can't see. One that I've already done because I don't really want to type it out again. But here you can see the first line of everything is going to be your base image. So this is going to pull it down from a Docker directory, kind of like GitHub, but it's like a kind of Docker hub. And this contains your OpenJDK number 8. Okay, so this is the base image. You'll need this for any Docker image you create. Now what we're going to do is we're going to copy this jar file on to our Docker image, okay? So we can do that with the add command. So we add our target folder / library / service.jar, and we add it to / app on the Docker image, okay? So again, base image, second one, we add the jar file from here to a file path on the Docker image or container / app. Then our next thing is we want the Docker image / container to run the following command. Okay. Now what that's going to do is it's going to run the Java jar command and spin up this library service jar file that you've copied onto your Docker image. Okay. So when you run this Docker container, it's saying, okay, run this library service that you've copied into, run this jar file, this library service jar file that you've copied into this file path from the previous step. Okay, and the final thing that, the final kind of line that we add here is the port. So you want to expose this container on port 8080. Okay, and that's the most simple Docker image that we can do for now. Okay, so it's pretty much telling, it's the Docker image, pretty much instructions for how the Docker container should run. So next thing we need to do is to build this Docker image. So again, if you guys have Docker installed, you can type in Docker images. Okay, so you can see here that I have a few images already. So I can go ahead and remove the image for B. Oh, because it's using a container. Sorry, so Docker, I'm just going to get a clean Docker environment so you guys can stop the container before. Okay, so we have done that. So if I just have a look and see which Docker containers are up and running, we have no Docker containers. And for the Docker images, and then Docker remove. Don't worry about all of this. I didn't clean this up before. Oh, CLS. No. Yeah, I didn't clean it up before. So if I have a look at the Docker images, right, okay, I just have one, just OpenJDK. That's because I downloaded it before. But let's see. So make sure you're in you open a terminal in the root directory of your project. And then the command you want to type is docker build, and then you want to give it a name. So -t, D for tag or name. I'm going to call it library service, and then dot. So the dot means here in this directory. So what this docker build does is it picks up this Dockerfile and builds you an image. Okay, so you can see I only had one image before, but now let's have a look. So once I build that, you can see the steps. So as you can see, I had 4 steps, okay? And here, there's 4 steps in the Docker image, okay? So now, if I do Docker images, you can see here that you will have your library service tag as latest, and it gives you an image ID and the size. If you're doing this for the first time, OpenJDK will have to download for you. That would be step 1. So yeah, it probably might take a bit longer because I think it's like, I don't know how big it is, but it's quite large. So it might take you a bit longer. So now we have that Docker image. So again, if I type in Docker images, we have this library service. So now what we need to do is run. So if I bring up Postman here, okay, if I do a get, nothing's working because I don't have the application running, and you know it's in error connection refused because nothing's running. Okay, so again, if I do it again, nothing's working. So we pull that out the way. Now what we want to do is run this Docker image. So pretty simply what we type is docker run, and what we want to do is type in p for ports and 8080-8080 and the image name, library service. Okay, so let's just run that, and you can see here that it is spinning up your application. So if I bring Postman back over and I do a get, you can see that now we are getting a response coming back from the Docker image or the Docker container. So our library isn't running up here, but we're getting a response from the Docker container. Okay, so if I open another terminal here, because I didn't put the logs in the background or make it run in the background, so it's going to be open here. But if I open a new terminal and I go docker ps-a, that command means show me all the containers that are active. And you can see here that I have run the library service. It's been up 52 seconds. Now, basically, the command I put in before was, if I go back to the main terminal, was docker run -p 8080 to 8080 and the library service. So this -p basically means map the inside port 8080 to our outside port. Now, I think this is the outside one and this is the internal one. So this one here, the expose 8080 maps to one of these. I think it's this one. I'm just not too sure at the minute. We can test it out anyway. And then we could change this one to like 8070. So let's do that now. So if I close down this actually CLS, and if I go docker ps-a, so it's still up and running. If you want to close it down, what you need to run is docker stop. So you can stop it, and you can just type in literally the first 3 characters of the container ID. So I've stopped it, and then I can remove it. So 116b. So if I go docker ps, there's no containers anymore, but there is still, and docker images to see all the images. Docker ps to list the containers, docker images to list the images, docker stop to stop the container, docker remove rm to remove the containers. And if you want to remove an image, it's docker rmi, then the image ID. So you can see here, no containers up and the library service. So if I pull up Postman, I do send, it's going to type. So let's do a docker run again. And this time I'm going to map it to port 8070 to 8080. Now, let's see if it is that way. And then it's the library service. Okay, so let that run. So now if I go to Postman and I change this to 8070 and click send, yeah. So I was right in saying that this here is your local machine's port that you want to map to the container port that the application is exposed on. So you can see here on Postman, when I do a request to 8070, it sends and forwards a request onto 8080, the Docker container. So that's pretty much all that we're going to do today. On the next tutorial, we'll add in Docker Compose and an API gateway. And all requests will route through the API gateway, and it will send it on to our library service. We will probably use Spring Cloud Gateway. So yeah, stay tuned, and hopefully this was of use to somebody out there. Thank you.